Yeah, close. Not quite right, but close. Oh, that's right. Okay. Let's have a look. So, what page are we on now? No, we are not. We are on 92. If you remember, I said we can remove 90. So we are on 92. So we're going to have a look at now, a basic look at histograms, very basic. And a very particular type of histogram called a normalized histogram. So let's see, 10, 4, 6, 7. KJ?
Yes.
Keys? Thank you. Okay. Have you got that? Yeah. So this is more of a topic for the business students, but for engineers you need to have a basic idea on this type of graph called a histogram. So histograms are used firstly for, now I don't think I did this word with you. Have I done the word continuous data with you? I said that. No. So you use a histogram for when you have continuous data. Examples of continuous data will be height and weight and time. In other words, it's data that could really be any value between two numbers. So like for height could really be any number from like 0 to 300 centimeters or whatever. And weight, again, is any number between 0 and, I don't know, 500 kilograms or whatever. Anyway, whatever. Continuous data, it can take any value between two endpoints. So for this type of data we use a histogram. So usually we start off with a table of the data, like for example something like this. So if we're talking about height, I'll just make 5 boxes here. 1, 2, 3, 4, 5. In this box here we'll have our height, which will be in centimeters. So let's say that is something like 150 to 159, and 160 to 169, and 170 to 179, and 180 to 189. And then here we have our frequency. Frequency means what? What's it? Oh, for goodness sake. No, stop. That's not what I mean here. That's physics. Even though
for one of a time.
Yes. What do you think I mean here with a table like this? Frequency. I can't believe you said that second. You make teachers sad. What do you think frequency means here? Just English, basic English, not physics.
The most repeated numbers.
Yes. What does it mean? Not quite that, but closer to that. What is it? Did we not do this word? Oh my goodness, will you look at page 84 please before I get very angry? What's frequency mean? Look at page 84. Do you remember this lesson? So what does frequency mean? You had a whole lesson on it. On page 84. You cannot tell me. You don't remember the name or the meaning of the title of the lesson even. Is that what you're saying to me right now? That on page 84 we did a lesson about frequency and you can't even tell me what frequency is after doing the lesson?
The total number in that section.
Yeah. The count. The total. How many? Yeah. Hurts. Goodness. Now, I'm very concerned about your test now next month. Very concerned. 3, so let's say 3, 5, 6, and I don't know, 2.
Well,
All right.
remember the formula one more time.
What is it?
For your shift request.
Yeah. Write this down before you get some trouble. Write this table down.
It's sure he's studying physics.
Yeah. Yeah, actually, that is showing that, isn't it? Okay, you got that? Yeah. So, this first we need to calculate the lower and upper boundaries. So for the first one, what's the lower boundary? 149.5 to 159.5, and we have 3 in this in class. The second class is 159.5 to 169.5. And we have 5 in this class. Next is 170, no, 169.5, 179.5, and then the last one, 179.5 to 189.5. And here we have 6 and 2. So how to represent this data, this table in a graph? Well, we use something called a normalized histogram. So let me show you how to make a normalized histogram and what exactly it is. Now, a normalized histogram looks a lot like a bar chart, but it's not quite a bar chart.
It's like the lines there.
Yeah, on the x-axis, you have your height. So we have here, for example, 140, 150, 160, 170, 180, and 190. So the first class goes from where to where? 149.5, which is about here, to
159.
159.
How is 149 close to 140?
It is not.
Oh, you do.
149 to 159.5. And the next one goes to 169.5 and 179.5 and then 189.5. So don't draw this yet, but what will happen is we're going to have bars, and this is what a histogram looks like. And the bigger the bars, what do you think? The more frequency. But we calculate the height in a very special way. So the height, firstly, the height is not the frequency. So for example, don't do this. It's not, oh, the first one is 3, the next one is 5, the next one is 6, and the last one is 2. It's not that. We put something different on the y-axis. We put something called the density. And you can use the same symbol as physics, if you like. The density symbol, if you want.
That's so one.
Yeah. Density. So we put density on the y-axis. Now, how do you calculate the density? So watch carefully. Watch. Firstly, you add all the frequencies together. So what do you get here? Yeah. Now hang on, that's enough of that now. I want concentration. So what do we get here?
16.
Is it 16?
That's
9, 10, 11, 16. Okay, so first you get the total. The total is 16. So you take all your frequencies and you divide them by 16, firstly. Is that okay? Yeah. Then what you do is you measure how big each class is, the class width. How big is each class? 10 apart.
Yeah.
So for the first one you divide by 16, yeah, and you also then divide by 10. How big is the second one?
10.
So you also divide this one by 10, and then this answer here, divide by 10, and this answer here, divide by 10. So the first one, 3 divided by 16, and then divide that answer by 10. So it'll be something like about, I don't know, 2 or something. What is it?
No, 0.0187.
0.06. So it's very small then, is it?
Yeah.
Right, see it on the screen. So the first one is 3 divided by 16 divided by 10. Yes, it's quite small. Let me just write the numbers down. I'll squeeze them on the top here. 0.01875. The next one? 0.03125. The next one? 0.0375. And then the next one?
0.0125.
It is, say again?
0.0125.
0.0125. Now these are what you use as the height. So what is the biggest height there? 0.0375. So what I'll do is I'll go up to 0.04, and here will be 0.02, this one will be 0.03, and this one here will be 0.01. So how big is the first one? To about here. And then the next one? It'll be up higher to about, yeah, something like this. Then the next one will be the highest. It's nearly at the top. And then the last one, 0.0125. So there's 1. So it'll be about here. But it should be a little bit bigger than the last one. So this is the histogram. Lower? Oh, sorry, yeah, it'll be a bit lower than the last one. So this is our histogram. Now what I want you to do now for me is to get the area of each rectangle. Now you have the heights up here. Here are the exact values for the heights. Did you write those down? Well, you can see them there. That's 0.0125. So I want areas, okay? Give me the area for each.
Just one to over 10, so 0.1.
So this area will be 0.1875, and this area will be 0.3125, and this area 0.375, and this area 0.125. Add those 4 numbers together. Add those 4 numbers together.
Stephen?
Yep.
Can I use integration?
For what? The area?
1.
But you don't have the function.
1.
It's 1. Yes, it should be.
It's 1.0.
No, it's 1. Exactly. If you use all the decimal places, it's 1. You did not. It's 1. Did you get exactly 1?
Yeah.
Yeah.
1.015.
What's your first number? 0.1875?
Yeah.
Plus
3.3125.
3125?
Yeah.
3125. Let me fix that for you, KJ. Now, this histogram, its purpose is to show you proportions. The total here is 1. That means the total area is 100%. What was the first area you got? 0.187.
Yeah.
So we'll say 0.19.
Okay.
As a percentage, what's 0.19? 19%. Yeah. What was the second one?
31%.
31%?
Yeah.
The next one?
37.
37, and the last one?
13%.
Okay, so the first one was 19. So what that means is 19% of your data was between these two numbers. The area represents percentages. That's what this histogram means. So what was the percentage? What was the area of this rectangle?
31.
31. So 31% of the data is between what two numbers? About 160 and 170. Okay. So by using this method to calculate the heights, what you've done is made rectangles whose area represent the percentage of how much of the data is between the two values. That's what a histogram is used for. So which rectangle had the biggest percentage? 37. That's this one?
Yeah.
So 37% of the data was between these two numbers. Okay, now, if you think about it, if you go back to your table, you can't, if I look, just forget about the histogram, if I look at this table, how much of the data is between 155 and 165? Look at the table. How much is between 155 and 165? Do you have that? No, you don't.
No.
Why?
Where's 155 on the table?
No, I thought you have all of this.
Yeah. Oh. Do you have a 155 to 165 box here? Do you? No.
No.
I mean, you have 150 to 159
yeah.
and 160 to 169, but you don't have 155 to 165. But if you look at the histogram, you could mark that off. Where's 155? It's around about here.
Yeah. So it's covered.
It's covered. 155 is here, and 165 is here. If you calculate this area, you have the percentage of how many are between 155 and 165. Yes. So, for example, how big is the base of this first rectangle? 155 to 160. That's 5. And then 160 to 165? 5. So there's 5 here and 5 here. What's the height of this one?
0.1.
Yeah, so can you give me the area for this half? And then KJ, can you give me the area for the second one? And then we'll add them together. Okay, so what did you get, Fahad?
0.4685.
For the first one?
Yeah.
Yeah. 0, so keep that on the calculator. What did you get for the second part?
0.15625.
Alright, so add that onto
Say it again.
0.15625.
Thank you.
5.508. 0.625.
That seems too big. One of you did something wrong. Well, maybe not. What else did you get originally?
I got 0.46875.
Ooh, 4 what?
4, 6?
Dang.
0.46.
That is very big.
That is very big. What did you do? 5 multiplied by?
I divide the.
What did you do? Now tell me how you got that number.
Magic.
No, tell me how you got that number. How did you get that number?
I multiplied by the height into 1.841.
No. Fahad, stop. How did you get that number you just gave me?
I divide by 2 and 20.
But why? That's not what I asked you to do. No, don't stop. Stop. I'll do it myself. Thank you. Right, so the first one. How big is the base here? 5. And the height? 0.1875.
No. 0.01875.
Ah, 0.01875. Yes. And then the next one is 5.
Yeah.
And the height?
0.03125.
3125. So the area in black is 0.25.
Yeah.
Seems better. So I'm saying that 25% of the data of the heights are between 155 and 165.
How do you know 20% of the data?
25% of all data is in this section.
Because the area of the black piece is 0.25.
Because the area is 0.25.
Yes.
Does that mean 25%?
That's what I've been saying for the last 5 minutes.
Because the total is 1 if you 0.25.
I know what you are doing. How to get the area? It's like easy to get the
Yeah.
area.
The area, like I said 5 minutes ago, the area represents the percentage, how much you have for that data values. So for example, what was the area of this rectangle?
37.
0.37.
Yeah.
So that means 37% of the data is between these two numbers. So 37% of your heights are between 170 and 180. The area of this black piece is 0.25. That means 25% of your height are between 155 and 165. Yeah? You got that now?
Yes.
You sure?
Yeah.
I don't know sometimes. I don't. This is very important for the next lesson. So I want you to draw a histogram. I'll tell you which ones.
Oh, no?
No, now. Three and four. Question 3, question 4. I want you to do that now.
They're very long.
Just do 3 and 4 for the next 10